This is the next question. And we are going to try to use extremality using our principles from earlier. So what is the setup? We have two n points on the plane. Okay. So n is some number. Don't just already follow Polya's advice and just think of n as 1, 2, 3. So, and there are, so in this example, n is 3. So there are 3 farms. So 3 of the points are farms. Okay. So in this diagram that is drawn, or this picture next to the question, see, these are the farms. I don't know. Yeah, these are the farms. And then there are some lakes or some wells. So there are 3 farms, let's say F1, F2, and F3, and there are 3 wells, W1, W2, and W3. Now, oops, that was unintended. How do I zoom out? Okay, wait. Let me erase the points and draw them somewhere else. So what do we want to do? We want to join each farm to a well by a straight cord. Okay? Think of it as a pipe. So here are some 3 farms and some 3 wells. So here is F1, F2, F3, and well 1, well 2, well 3. There is no need for them to be arranged in this special manner. I'm just taking an example. And in this case, it's very easy to do it, right? Just join F1, F2, F1, W1, F2, W2, and F3, W3. We want to join them by a straight road. And we want to actually show that this is always possible. No matter how you place the farms and how you place the wells, you can join them by a straight road. So one farm to one well. Okay, exactly one farm to one well. The important point is that no 2 roads should intersect. So for instance, if this is F1, this is, let's say F2, I'm just taking another example, and this is W2 and this is W1. Then if you join F1 with W1 and F2 with W2, this won't work. This won't work because this has an intersection over here. This is not allowed. Yeah, but there is an easy solution. In this case, I guess you guys can see the solution. It is just join F1 with W2 and join F2 with W1. Right? If you do that, then the 2 roads are not intersecting. So this is the solution. F1, you join F1 to W2 and F2 to W1. So you want to join each farm to one well. Okay. So 2 wells can't be allocated to the same farm, and no 2 farms can be allocated to the same well. So one farm to one well in such a way that these line segments do not cross each other. And we want to show that this is always possible, no matter how these n farms and these n wells are placed on the plane on R2. Okay, so there is one important fact in the problem which I did not mention, that no 3 points should be collinear. Because if that happens, if 3 points were collinear, then there is no chance to do anything, right? And you can already see that. So suppose these 3 points are all on a line, and you call this F1 and you call this F2, and let's say this is W1, and okay, and there is W2 also. Then there is no way to join F1 to either W1 or W2. Like, all these roads are going to lie on that same line, and there is going to be a heavy intersection. So it's not possible. So we assume that no 3 points are collinear. And then we want to show that it is always feasible to join the farms and wells with roads. So if the question is not clear, please let me know. I'll try to clarify the question. So, okay, if the question is clear, I'll move on and I'll get you started with the problem solving process. And then I'll leave at some point, and then you guys will have to fill in the blanks later. So let's try to think about what to do. So, okay, I'll follow Polya's principle. I'll start with very small values. So 1, there is nothing happening, like what to do. There is F1 and W1, just join them. There is hardly anything. This is not really capturing the spirit of the problem. So let's forget that. So let's try n equal to 2, right? So if there are 2 points, so I think these, if there are 2 points, so let's say F1, F2, W1, W2, or it could be W2, W1. There are two ways to join them. This is obviously the incorrect way, but this is the correct way. This is the correct way to join. And okay, so for the case of n equal to 2, it seems almost visually true that this is always possible, right? No matter how you arrange the points, it's always going to be possible to choose F1 and to map the point farms and wells so that there is no intersection. Of course, I haven't proved it, but let's move on and see what's happening for larger values. So let's go ahead for n equal to 3. Sorry about that. I think every time I touch the screen, it seems to take it as input. So n equal to 3. Now there are 3 farms. I understand now what is happening. I cannot put pressure over it, otherwise it. So there are 3 farms and 3 wells. In some way, distributed in some way, we do not know. So there is farm 1, farm 2. They can be mixed in weird ways. There is no need for them to follow any particular strategy. This is W3, W2, and W1. Now we want to connect the farms to wells such that no two cross each other. Okay. So I'm thinking that, okay, this is again very easy to do. I can't connect farm 1 to say, okay, 1 second. Let me, just so that it is not misleading, let me relabel these numbers, because every time you're connecting it, so this is, this is well 1.
There's a question.
Yeah.
Is there a constraint like each well is meant for each farm?
No, there is no such constraint. So farm 1, it need not be connected to well 1. So let's consider this example. Okay, the example that I'm drawing. So in this example, what would be the connections? What is one way to fulfill the requirement? Just connect farm 1 to W2, W3 to farm 2. I'm sorry for that. W3 to farm 2 and farm 3 to W1. This would satisfy the requirements of the question. Okay, the connections that we have drawn. Now, still we are not quite sure what is happening, right? At least I am not sure what is happening. It seems like we are visually able to suggest that this is always feasible. Even for the case of n equal to 3, we are not quite sure whether all cases are feasible. You just drew a case, and since the question is saying it is feasible, of course it should be feasible. But if we are in general doing it for a large value of n, a very large value of n, like let's say 4, 5, I mean, not very large, some other larger values of n, what's going to happen? Okay, we are going to again imagine by contradiction that there is some configuration of points. There are lots of points. Okay? There is some configuration of points of farms and wells, of n farms and n wells, such that no matter how we try to join them with straight lines, we are unsuccessful. Okay, this is the contradiction of the question. This is assuming that the question is false, right? You guys know this. Now, let's try to make this local improvement thing that we were saying, right, in our principle. So let's take some way of joining them. Like when whatever way of, no, this time I did not even touch the screen. So whatever way of joining them I choose, right? So this is some farm. It doesn't even matter which. So this is some farm I and well j. So this is just an index, right? I hope this does not confuse you guys. These are I and j are just placeholders. And let's say there is this farm, there's this different farm. So let's call it A and well B. Okay. And somehow, no matter how you try to join them, there is always this crossing. So in this case, here there is this crossing, right? There is a crossing that we have, and that's why we are not successful. Now, can you suggest a way to get rid of the crossing? There is a very natural way to get rid of this crossing. Does somebody want to suggest the way? So, okay, what have we done? We have considered a collection of points on the plane. Someone has told us that, no matter how you try to join a farm to a well, you will always run into issues. There will always be crossing in the roads. then we say, okay, let's consider some such matching. Like, let's consider some such way of joining the farms to the wells. And you show me a crossing, right? Because that's what is supposed to happen. I'll always end up with a crossing. So here's the crossing I see. Is there a way in which you can like improve the situation here? There's a very natural way, right? So improving the situation, what would it mean? It would mean just get rid of this crossing. Does somebody want to suggest something? So what does it mean improve the, so what can we do? I think probably the rules of the games are not clear to you. So what can we do? We are free to choose any well for FI and any well for FA. We are not forced. Nobody is forcing us. Like here, nobody was forcing us to join F1 to W1. You can join any farm to any well.
Except you have to do it uniquely.
Yeah. 1:1. 1:1. It's always 1:1 that we have established, but there is no constraint on us saying that FI should go to WJ. There is no constraint on us saying that FA should go to W. What is the modification you can see here on the picture at least, which would get rid of this one crossing? I'm not sure.
Sorry,
Yes.
FI with WB and FA with WJ, Shubhajit says.
Yeah, that's great. I don't know if the others are following, but I'm going to assume. So this is a great suggestion. That is, why don't you just forget this red part, because that's problematic, and let's just join FI with WJ and FA with WJ and FI with WB. So replace the red ones with the green ones. Okay. So let me actually do it in a different way. Just give me a second. Let me not do it this way, in case it is confusing. Yeah. So what is being suggested is that you take this thing and you instead use these dotted roads instead of the red roads. Okay. So your situation will look like this. This will be FI. This will be FA. This will be WB, and this will be WJ, and you will have these roads now. So what have we done? It seems like the crossing that was causing us a problem, we got rid of it. Right? We got rid of the crossing. So it almost feels here that, oh great, why the hell can I not keep doing this? Every time I see a crossing, I will go there, I'll look at those 4 points which are a problem, because a crossing will involve 4 points. Right? It will involve a farm and a well and a farm and a well. And I will go and just do this maneuver. And the hope is that the number of crossings, right? You started with a configuration. Let's say N was 4 or something. You started with a configuration. There were a certain number of crossings. This configuration is a problem. If there were 0 crossings, we would have already satisfied the question. So there are some number of crossings. And you keep doing this process. You go to a crossing, you try to do this process of unraveling the crossing, right? You connect the appropriate farm and wells. What is the issue in this argument? Can someone tell me? That I keep on doing this. So I don't care what is the value of N. Let's just, for this, let's assume N is like 42 or something. I say, okay, I have these 42 wells, these 42 farms, just connect them anyhow. I don't care. Okay, then you will say, oh look, 10,000 crossings came up. I'll go over the crossings one by one and correct them. I'll use the procedure I just told you. Go over, pick one of the crossings of these 10,000 crossings, make this modification, that crossing is no longer there. And then my idea is that I'll just keep going. I'll just exhaust all your 10,000 crossings one by one. There is no time constraint here. Like, it's just a matter of whether it's possible or not. So do you guys think this is a correct argument? Because this is essentially showing that at the end of this procedure, all the crossings will be removed. And if there are no crossings, then, well, you have satisfied what the question asks. I feel like I might have lost people here. So please ask questions in the chat. I'll give you guys a minute to think about what's wrong in this argument. This argument is not correct, the one I'm giving.
So Shubhajit says fixing one intersection might lead to the might generate another intersection with other lines.
Yes, that is correct, Shubhajit. Do Ishan and Drinmay follow the problem with the argument? Do they follow the argument? Yes or no? Do you guys follow what we were trying to do?
Brandmeier says, yes, we did. We can always get rid of the crossing for a small n, but how to know for many, many points, like how to prove we can make one connection anyhow.
Okay, wait. We will address that. So Ishan, do you follow the argument?
Like, yeah, he said yes.
Okay. So Mridmay, I guess you are asking that if we get rid of one crossing, how do we know that we get rid of all the crossings? Or yeah, I just you can also just do a thumbs up on your screen if that is what is being asked. And I think you are also asking that I don't know if this is something you're asking, that given a say n is 42, given 42 wells and 42 points, why is there even one way of assigning the farms and the wells? Like initially we assumed that there is some configuration. There is some way to map the farms to the wells. So, okay, I'll say it in a different language where it will be clear. In the beginning, just connect farm 1 to well 1. Connect farm 2 to well 2. Farm 3 to well 3, farm 42 to well 42. This will create a lot of crossings. A lot of crossings. Go over the first crossing. So, just collect all the crossings, note them down in your notebook, pick up the first crossing, modify it, correct it. Correct it using this procedure. So that crossing is gone. Now go to the second crossing in your notebook. Correct it using this procedure. That crossing is also gone. And you keep going, keep going. If n were 42, there cannot be more than some finite number of crossings, right? There cannot be more than some 40 to choose 4 crossings. You just go over all of them. But as Shubhajit pointed out, that when you correct a crossing, you might create new crossings which were not earlier there. So a crossing which you had, so suppose this farm FIWJ FAWB crossing, right, which was corrected. This
you can show that. You can show. So maybe in this FIWB FAWJ picture, make one more connection between SK and WL maybe.
Yes, that's what I'm going to do.
And just show it.
So it could have happened that there is this other well FK and there is this other point WL, and in your original diagram, where that is in the initial matching that you configuration that you considered, why that you considered, this is what was there. Okay, this was the diagram. Oh, sorry.
It's better to put the SK inside the triangle.
Yeah, I think I drew the wrong WLs. So the FK should go inside the triangle. Yeah, let me just use this. I can't change the colors. So this, why? This is FK. This point is FK. And this well is WL. And they were initially connected, happily connected, without any problem. Now, when you revert to the green configuration, see, in the red configuration, FI and WB do not exist. That road is not there. So this crossing is not present in the red configuration. But the moment you go to the green configuration, this crossing starts to exist. So you created a new crossing. So at least this method of exhausting does not directly work. Okay, so now the next question to you guys is that, do you think there is a way, I'll not give you too much time to think about it, but do you think there is a way to correct the assignments in such a, to make these corrections of crossings in such a way that we don't keep on producing new crossings? I think probably Ishan got disconnected.
He's there.
Who is there? Okay. So, yeah. Let's just think about this. So like in this example, for instance, right, here we see that Fi and Wj and Fa and Wb are a bad pair, like they create a crossing. And when we try to correct them in the most natural strategy that we had, this FKWL pair caused a problem. It created an even further crossing which did not exist. So what we are in danger of is that every time we correct a crossing, we create a new one. Every time we correct a crossing, we create a new one. Right? Then this process is not going to end. It's just going to keep on going. That's not helping.
Prabhajit's question is, do we have to find a strategy or do we have to show such configuration exists without intersection?
We want to show that such configurations exist without intersection. That is the question. But if we can find a strategy, even that is good. Right now, we are not trying to really find a strategy to give the layout of the roads. What we are trying to do is actually understand what is the parameter on which we have to use extremality. Okay, so fine. Now let's come back to what we did. We realized that this approach looks natural. This is the local improvement that we were making. We took a crossing, improved it. There's a subtle flaw that we also realized. It keeps on generating new crossings and there is no way out. Like in this current configuration of points, Fi, Fa and Wb, Wj, with the Fk point being inside that triangle that is displayed, the only local way to correct Fi, Fa and Wb, Wj is the one that we are showing in the diagram. But the moment we do it, we are creating one new crossing. There is just nothing. There's no other way of doing it. Of course, there is a cleverer way of connecting Fi to Wl, Ft to Wb, and Fa to Wj. But then this argument, so either you have to follow that line of thought and see whether that argument gives something. Okay. But let's come back to the way of extremality we are trying to argue. So here the question to you then is that, okay, when you make this improvement, your initial thought was to use the number of crossings as the extremal parameter. Had this argument worked, okay, so let me say it in a different way. Had this argument worked, you would have said, okay, take that configuration of roads between the 42 wells and the 42 farms such that the number of crossings is as few as possible, right? With the lowest number of crossings. Either that number is 0, in which case we are done, or if that number is not 0, if it is 1 or more than 1, I will show you how to reduce the number using this trick. Had this worked, this does not work, but had this worked, you would have showed me how to reduce the minimal number by even one more, which is a contradiction because I started with the configuration which had the smallest number of crossings. Okay, so this parameter is not going to work. Number of crossings is not helping us. But can you see something, some other parameter in this configuration of points? I'm going to draw it out again for you. So can you see some modification? So we started with the red configuration and we end up with the green one. Okay. Can you see some modification or some parameter here which is clearly improving, or in fact, let me even tell you, reducing? Number of crossings is not reducing because we saw that. Is there a different parameter here you can see in the diagram which is reducing? If you can get that parameter, well, then you already know. That's just plug and play into our template. We'll use an extremal configuration of that parameter and get a configuration. So I give you guys a minute to ponder on this. It's not the most obvious parameter, but it is not completely magical also. It is present in the title.
Shubhajit has a response.
Yes.
Right.
Wait for...
Yeah, okay.
Is the question clear to everyone? Is that a clarification question or is it an answer?
It is not a clarification. It is a suggestion as to what is improving.
Okay, so we will take it up in a minute. But Mrinmay and Ishan, do you guys follow what is going on? Yes or no?
Ishan said yes.
Okay. Have we lost you, Mrinmay, or do you follow what is going on? You can just do thumbs up. If you can't, then thumbs down. Or in between. That please don't. Or if you're writing on the chat to me, I won't be able to see it. So if you're writing on the chat, write it directly to Poonam or to Shekhar.
We know that number of lines are a parameter. We can't prove it. And now you want us to look for another parameter? So I think he meant number of intersections.
Yes. I don't know who is asking this, but yes. Yeah, exactly this. This is what is going on. We wanted to show that the number of crossings is going down. That did not happen. So we are looking for a different parameter. Okay, so if there are suggestions, then please write. Subhajit already suggested something. If you guys have suggestions for other parameters which are evident in just this diagram at the bottom, you don't have to search for it everywhere. Then please write.
So yeah, Shubhajit, number of line segments will be constant. There will be exactly n line segments.
Yes, the number of line segments are always constant. The number of crossings is what we are trying to get rid of. So I guess we can now take suggestions. So what was Shubhajit's suggestion?
So he said that length of line segments, that's only said, length of line segments.
Yes. So one suggestion is length of line segments. Is there any other suggestion by anybody? Length of the road. Length of line segments here is just length of the road, which are our roads. Yes. So this is an excellent suggestion, Shubhajit. It works here. And if you think about it, it will look magical. Had I told you about this thing in the beginning, that let's look at the configuration which minimizes the length of the line segments. But from this diagram, it shouldn't look so magical. Because one parameter we can see here. Now, see here, this is the smelling part of it. This only comes with experience. Right? Everything, yeah, there is some creativity that will remain. We can't distill away everything. So let's call this point something. Let me call this P. This point, let me call it P. See, one thing we can observe is that the sum of these green roads, the sum of the length of the green roads is less than the sum of the length of the red roads, right? Why? Because of the triangle inequality that you guys know. FIP plus PWB.
Siddharth, you can just use a laser pointer to show it rather than writing. You think writing will just distract it?
I'll do both then. So this FIP plus PWB is going to be more than FIWB because of triangle inequality. Similarly, FAP plus PWJ is going to be more than FAWG by triangle inequality. But if you just sum up the two inequalities, the conclusion is just that the sum of the red roads is greater than the sum of the green roads. So let me quickly also, despite Abhishek's objection, write it down and then not sum it up though. FIWB. This is the first inequality. And then the second inequality is FAP plus PWJ is greater than FAWJ. And you just sum it up. If you just sum this up, you will get exactly what we were suggesting. FIWJ plus FAWB is greater than FIWB plus FAWJ. Okay. So this is the main inequality that we are after. So the length of the roads has gone down by this modification. Do I have now? Okay, what is the remainder of the argument? This you guys should be comfortable in now. This is just plug and play. We would have started with the configuration which had the least length of road connecting the farm to the well in a one-to-one fashion. If there were a crossing, we would obtain a configuration with even lesser length. So that configuration, that minimal configuration we started with, has to have no crossing. Okay. So I hope some part of it is clear. So let me just write it out very briefly. So start with. So this is just a symbol for with, or let me write it. Start with a connection of farms and wells with minimal road length if there is crossing. Is this because I am even on? If there is a crossing, then we obtain a smaller. Patience is needed. Obtain a connection with lesser road. Okay, and this is the idea that if you have such a connection, such a crossing, this dotted crossing has even lesser length than the connection you started with. Okay, so I hope this thing is clear. So the main equality we are saying is AB plus CD is greater than AD plus PC. Okay, so if there are questions, please ask. Or else we will move on. So we haven't given a very rigid proof, like an airtight proof, but I am confident that you guys can fill in the details from this point, because it's just going to be plug and play into our framework.
Subhajit has a remark.
Yes.
Wow, that's an amazing solution. It's so elegant yet simple if we thought about the minimum length configuration.
Yeah, it is quite amazing that this such a nice characterization as minimal length can actually capture no crossing. And it is very mystical. Like the first time I would have done this question, which would have been probably more than a decade ago. Yeah, roughly around then I would, I mean, it was quite magical to see all these questions. Like extremality, the parameters on which people use extremality are really innovative. Yeah, there is just no end to how creative you can be on this. But it is truly amazing, this solution.
This is such a non-trivial problem on the face of it. There could be potentially so many connections. You have to take care of the geometry of the plane. But somehow this solution is just one line.
Yeah. What we are hoping to do is make it less magical in some sense, to tell you how someone would think of this. How the hell is minimal road length something that comes to someone's mind when crossings have to be removed? It doesn't come like there's at the face of it. I could never guessed it. But once you get trained in it and you understand that this is how the thought process goes, you will see that you can do this as well.
The local fixing is a very general theme. It works in many problems. Yeah. Locally, you start with some configuration, then you try to fix it. The really interesting problems are those where local approaches don't work.
That's true. Like there are problems especially in research math, where a lot of the time the fixing happens at a very global level, and that is when the mind starts to bobble. Like again, what's going on? So if there are no further questions, I'll move on.